In this video, we're going to walk through problem 518, which asks us to calculate the bond equivalent yield, the effective annual return, and the future value or face value at maturity of a CD. We're told the bank issues a 6-month negotiable, $2 million negotiable CD. Now, the 6 months isn't particularly precise, as some 6-month periods are longer than other 6-month periods. Typically, our CDs will be issued for 180 days, 120 days, 90 days, not really 6 months. But in any event, we're going to work with the 6 months and assume there are 2 6-month periods in a year. First thing we are asked to do is calculate the bond equivalent yield. So we just need to take the quoted nominal yield and multiply it by 365 and divide by 360. And that's going to give us our bond equivalent yield. Then we need to calculate our effective annual return, and we can do that with our EAR formula, which in this case isn't too bad since it's a number of periods, or we could use our financial calculator, and we're going to get 0.5279%. And again, that would have just simply been taking the bond equivalent yield, dividing it by 2, and taking that to the second period for the 2 compounding periods. Next, we need to calculate how much the CD is going to be worth at maturity. That's just going to be the CD's issue value of $2 million plus interest. That will give us the value at maturity. So we need to calculate the interest. And our interest is simply going to be the CD's issue value of $2 million times our effective annual rate times the term, which in this case is 6 months or a half a year. So we get $5,279 in interest. Add that to the $2 million, and we get the value of the CD at maturity. Now, in the next part of the problem, we're told that if immediately after being issued, the secondary market price of the CD falls, we're asked to find the new quoted yield, bond equivalent yield, and EAR on the CD. Now, of course, if the price goes down, interest rate or yield has to do what? Go up. So we can simply use our calculator and solve for a 6-month interest rate. We have the new present value, which is the secondary market price. We know the maturity's future value at maturity. We just solve for that above. That's the $2,005,000. We're going to hold this for 1 6-month period. The CD doesn't make any payments, and we're just going to use our financial calculator or Excel to solve for a 6-month interest rate. And we get 0.3267. And again, that's a 6-month interest rate. To get the bond equivalent yield, we simply multiply that 6-month rate by 2, since there's 2 6-month periods in a year. Next, we could solve for the quoted yield, but we're going to do that later on. But we're going to take this 6-month interest rate and we're going to calculate the EAR. So if you still have that 6-month interest rate in your financial calculator, we can simply set the present value equal to 1, set the number of periods to 2, because there's 2 6-month periods in the year. The payment's going to be 0. And we can solve for the future value and subtract 1. Or we could use our formula for the EAR, where again our APR is the bond equivalent yield, and we can divide that by 2. And we really don't even need to do that because we already have that rate divided by 2 right there. So we can just take our 1 plus our point, and again, that's a 0.32%, so 1 plus 0.003267, and take that to the second power, and we would get our EAR of 0.6544%. Last thing we need to do on this problem is we need to solve for our quoted yield. Normally, and up top, remember, we took our quoted yield and multiplied it by 365 and divided by 360 to get the bond equivalent rate. In this case, we are working with the bond equivalent rate. So we simply need to multiply by 360 and divide by 365. So we're doing just the opposite. And we get a quoted rate of 0.6444%. And again, you could work the other way. Take that rate to confirm that that's what you would get for your bond equivalent. Take that, confirm that's what you would get for your EAR. Hope that helps in solving this problem.